Hey everyone, welcome to today's podcast Innovative Technological Interventions based on Kerala context. Today I'm just super excited because I'm just joined by some of my very charming friends on this podcast. So, first of all, let me introduce them to you. We have with us today Amrita, Helen, Pratibha, Siddharth, Aditya, Megha, and myself, Dia. And our topic for today's podcast is flood predictions in Kerala using machine learning. As we all know, Kerala, our own God's own country, because of its geography, it is very vulnerable to natural disasters, very specifically floods and landslides. As we all know, we have been hit hard so many times by the floods. We would remember the flood which took place in 2018, also which came back to back 2019. So I think this topic has a lot of importance in this present scenario. So without any delay, let's start with the podcast. I think Amrita is ready to start the podcast. Amrita, what do you think is one of the latest innovative technology that is going to help Kerala in this context?
Rainfall predictions have always been a complex task because weather isn't just random, it follows patterns that change over hours, days, and even seasons. To capture these patterns, we use a powerful machine learning technique called LSTM based recurrent neural networks. LSTM or long short term memory networks are a special type of RNN designed to analyze this series data. Unlike traditional models that easily forget all the informations, LSTMs have memory cells that allow them to hold on to important details for long periods. This makes them perfect for understanding rainfall behavior, where what happened last week or last month can influence what happens today. By training LSTMs on years of historical rainfall data, including daily rainfall amounts, duration, and intensity, these networks can learn hidden trends that humans might miss. Once trained, they can predict upcoming rainfall with much higher accuracy. This is especially valuable in regions like Kerala, where heavy rainfalls can quickly lead to floods. With LSTM based models, we can generate early warnings, prepare communities, and reduce the impact of natural disasters. So essentially, LSTMs helps us to transform raw rainfall data into meaningful predictions that keep people safer and better informed.
Thank you, Amrita. That was really informative. Helen, I've heard about logic regression. Can you please tell what exactly it is and how it is helping in this context?
So basically, logistic regression is a binary classification algorithm. That means it is used when we want to predict some outcomes. So if we want to see if there is a flood or not, we use logistic regression. It looks at different input features and calculates the probability of an event happening.
Okay, that was informative, really. Okay, ഒരു സെക്കൻഡ് ഞാനിവിടെ അടുത്ത പ്രതിഭ അല്ലേ Pratibha, what would you like to add up to this podcast today's session?
Today I were talking about decision trees, a basic and popular machine learning method. A decision tree works like a flowchart. It asks questions step by step to help make a decision or prediction. For example, in flood prediction, it uses past data and important features to guess when a flood might happen or how serious it could be.
Oh, really? Okay, then. I think it's time that we would move on to support vector machine. Siddharth, can you please add on something to this?
Support vector machine or SVM is a supervised machine learning method used for both classification and regression. Works well with complex data, which is why it is often used in flood prediction. In this approach, historical flood data such as rainfall, river levels, soil moisture, and topography is collected and cleaned during preprocess- preprocessing. Important features are then selected to clearly represent flood patterns.
Oh, really? I've also heard about this random forest. I think it is also an upcoming technological advancement. Who could add to this about random forest? I think Aditya, you're ready with that.
Yeah, Dia, I'm ready with that. So imagine we are trying to predict something, like whether a flood will happen, and we use a decision tree. A single tree is asking one friend for advice. Sometimes the friend might be right, maybe not. Now, the random forest says, why rely on just one friend? Let's ask a group of friends. So it creates many decision trees, not just one. But here's the interesting part. Each tree is trained on a random mix of data, just like how each friend gives a slightly different experience or opinion. So, every tree has its own answer. One tree might say there will be flood, and the other might say there will not be any flood. And the random forest takes a majority vote from all these trees. Whichever answer most trees agree on becomes the final prediction. Just like that, we are not depending on one tree that might overthink or make a mistake. We are depending on the wisdom of the entire group. And that's why random forest is usually more accurate, more stable, and less likely to overfit compared to a single decision tree. So, in simple words, random forest is just a bunch of decision trees working together to make a smarter prediction. I guess I've added up to what necessitates you.
Yes, that was well explained, Aditya. Thank you so much. I think evaluation matrices also play a good role in this context. Megha, what do you think about this?
Evaluation metrics have played an important role as it gives data about the situation. So, accuracy tells us how often the model is correct. It's simply the number of correct predictions divided by the total predictions. It's commonly used in classification problems. We have the recall measures, which tells us how the model identifies actual positive cases. It is calculated as true positive divided by true positive plus false negative. High recall means the model is listing pure positive cases. We have F1 score, which combines the precision and recall into one number using their harmonic mean. It helpful when we need a balance between catching procedures and avoiding false alarm. Then ROC curves are there, which plots the true positive rate against the false positive rate at various thresholds. It visually shows how the model performs across different decision settings. AUC stands for area under the ROC curve. A higher AUC means the model performs better overall in distinguishing between classes. That's all about the uh, evaluation on machine learning, metrics used in machine learning. Thank you.
Thank you. So, as we wrap up today's Innovative Technological Intervention podcast, it is super clear that the future of Kerala and its flood predictions is becoming more and more accurate, responsive, and more community centered. And thank you, my dear friends, for joining me today in this podcast. And thank you, our dear viewers. Keep learning, keep being informative on this topic. Thank you so much.